Hello friends, myself Rajendra Mahajan presenting my video on linear differential equation with variable coefficient. Try to solve the example. Equation is 2x plus 1 whole square into dy by dx square minus 2 times 2x plus 1 into dy by dx minus 12y is equals to x log of 2x plus 1. If we observe the terms power of 2x plus 1 and the order of that derivative associated with is same, and that's why it is homogeneous, and the type is Legendre's. And as it is in Legendre's form, to convert it into a linear differential equation with constant coefficient, we have to use the substitution 2x plus 1 is equals to e raised to t, and therefore t is equal to log of x plus 1 and capital D as d by dt. Original variables are y and x. Y is dependent variable, x is independent variable. We are using a new independent variable as t. T as log of 2x plus 1. Value of 2x plus 1 into dy by dx as a into dy. What is the value of a here? A is the coefficient of x, and therefore it is 2 times dy, and 2x plus 1 whole square into d2y by dx square as a square multiplied by d minus 1 into y, and therefore we get value of a is here 2 square is 4 d minus 1 into y. Substituting this in the given differential equation, that equation becomes, the value of this first term is 4 d minus 1, we can take y as common, then minus 2 times the value of 2x plus 1 into dy by dx is 2 dy, and minus 12y, minus 12 into y, and that is equal to x. We get the value of x from this as raised to t minus 1 divided by 2, and therefore substituting that value, we get the right hand side as x means e raised to t minus 1 by 2 into log of 2x plus 1. The value of log of 2x plus 1 is t. Simplifying it further, we get 4 d square minus 4d minus 4d minus 12 into y is equal to 1 by 2 times t into e raised to t and minus t. From all this term I can take 4 common, therefore 4 times we get d square minus 2d and minus 3 into y is equal to 1 by 2 times t e raised to t and minus t. We call this as equation 1. Or dividing by 4 throughout, we get d square minus 2d minus 3 into y is equals to 4 to the 8, means it becomes 1 by 8 times t e raised to t minus t. Therefore, this equation number 1 is linear differential equation of order 2 and with constant coefficient. The coefficient of d square is 1, coefficient of d is 2, last term is constant term. Therefore, it is LDE with constant coefficient. And after getting LDE with constant coefficient, we try to apply the technique to solve it. In first part we find CF, in second part we find PI, and then add that CF and PI to get the required solution. Therefore, before to start the new step, try to watch the video up to end so that all steps are clear to all of you. Auxiliary equation is here, d square minus 2d minus 3 is equals to 0. Factors are d minus 3 and d plus 1 is equals to 0. product is minus 3 and sum is minus 2. And if we equating each factor to 0, we get d is equals to minus 1 and d is equals to 3. Here the roots are real and different, and therefore as the roots are real and different, we write down the CF part as C1 e raised to m1x. The value of m1 is minus 1, therefore minus t. C2 e raised to m2x, m2 is here 3, therefore 3t. Equation number 2. Once again the scheme of marking for the substitution and the conversion in terms of equation 1, we get 1 mark. 1 mark for the CF, therefore 2 marks for the steps up to this. Then in next part we try to find out PI. Here there are two terms, therefore we find PI1 and PI2 and then combine that two PIs to get the PI. PI1 is obtained by inverse operator technique, 1 upon d square minus 2d minus 3 operated on e raised to t into t. It is in the form of e raised to x into v, and for that case the replacement for d is d plus a. A is the coefficient of t in this term and therefore it is d plus 1. Replace d by d plus 1, and while replacing it, take this e raised to t outside. 1 upon d plus 1 whole square minus 2 times d plus 1 minus 3, operate it on t. Capital V is here t. And then simplify it, e raised to t 1 upon, expand and simplify. Expanding it, we get d square plus 2d plus 1 minus 2d minus 2 and minus 3. Operated on t. Plus 2d minus 2d get cancelled. We get e raised to t 1 upon d square minus 5 plus 1, we get minus 4. Which way to operate on t? T means x raised to m type of term. And then we have to apply the technique to find pi for x raised to m, shortcut method. And therefore, applying that technique, we have to take the lowest degree term common. Here the degree of the first term is 2, degree of second term is 0. Therefore, this becomes the lowest degree term. We have to take it common, and therefore it is e raised to t. I will take minus 4 common. When we take minus 4 common from minus 4, remaining term is 1, and here it becomes minus we get plus d square by 4, and then transferring it to numerator, we get raised to minus 1, operating it on t. And we have to expand it by binomial theorem up to terms containing d only, and therefore here the power is d square, means when we operate it becomes second order derivative of t. First derivative is 1, second derivative is 0, and as that derivative becomes 0, we can neglect this step here also without finding the expansion, or find expansion and then neglect it. We get one and the same answer, and therefore it is e raised to t by minus 4. Neglecting this, therefore remaining term is 1 only, which we have to operate on t, and therefore we have e raised to t, 1 into t we get t, and divided by minus 4. We call this equation number 3. A PI1. Then we try to find out PI2. PI2 is obtained by again inverse operator technique. It is 1 upon d square minus 2d minus 3 operated on t, second term. Again the same form, x raised to m type, and therefore as it is in the form of x raised to m, we take lowest degree term common. Therefore minus 1 by 3 we take common. Remaining terms are, from minus 3 if we take minus 3 common, we get 1. Next here plus 2 by 3 plus minus, we get minus original sign d, and next one is minus d square by 3. Operate on t. Then it is minus 1 by 3. Transferring this to numerator, we get 1 plus 2 by 3 times d. I will neglect that d square. The same reason. D square, when we operate on t, second order derivative of t with respect to t is 0, and therefore as it becomes 0, we can neglect it here also before finding the expansion. Then transferring it to numerator, we get 1 plus 2 by 3 times d whole raised to minus 1, which we have to operate on t. Then expanding it by binomial theorem up to d only, and therefore its expansion is 1 plus capital X raised to minus 1. Expansion is terms alternately positive negative. Then minus x is here, 2 by 3 times d. Next is plus the square of this. Again, when we make a square, it becomes d square. D square, when we operate on t, its derivative is 0, and therefore we simply write down so on into t minus 1 by 3 as it is, and therefore minus 1 by 3 times 1 into t, we get t minus 2 by 3. Our derivative of t with respect to t is 1. Therefore we call this equation next, fourth one. After finding pi1 and pi2, put these values or take the addition of CF, pi1 and pi2 to obtain the required solution, and therefore we get required solution. Complete solution is nothing but complementary function CF plus particular integral pi. Therefore always it is for dependent variable. Dependent variable is y. Therefore y is equal to CF is c1 e raised to minus t plus c2 e raised to 3t plus pi. 1 by 8 is a common term. pi1 plus pi2. The value of pi1 is t e raised to t divided by minus 4, and the value of pi2 is minus 1 by 3 times t minus 2 by 3. We are getting the solution in terms of y and t, but the original equation is in terms of x and y. Therefore once again we have to convert t in terms of x, and therefore final answer is y is equal to c1 e raised to t is 2x plus 1, and that raised to minus 1. This e raised to 3t we can write down as e raised to t and its cube, and therefore it is c2 e raised to t is once again 2x plus 1 and its cube plus 1 by 8. This e raised to t is 2x plus 1, and into t is log of 2x plus 1, and divided by minus 4, minus 1 by 3 times t is log 2x plus 1 and minus 2 by 3. Therefore this 1 by 8 is common to these two terms, and therefore whatever this last step is the required answer or a required solution of that Legendre's linear differential equation, obtained by using this substitution. 2x plus 1 is equal to e raised to t. Therefore t is equal to log of 2x plus 1. Value of x is e raised to t minus 1 by 2, and capital D for d by dt. In my next video, I will discuss the problem of method of separation of variable. Please like my video, share it, as well as subscribe to my channel. If you are not subscribed yet, please subscribe it, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.